For most of human history, we viewed this dense band of light as the entire universe. The ancient Greeks thought it resembled spilled milk, which gave us the word galaxy. This diagram plots our modern reality. The observable universe stretches 93 billion light-years across and contains hundreds of billions, potentially trillions, of these massive structures. A galaxy is a massive ecosystem held together by gravity. Each one is a collection of stars, planetary systems, gas, dust, dark matter, and black holes. As we catalog these systems, we find they aren't uniform. They exist in a menagerie of radically different, chaotic, and beautiful shapes. Understanding the universe requires us to look past the empty space and dissect the anatomy of these fundamental building blocks. A galaxy requires immense internal anchors to survive its own violent rotation. Without them, the centrifugal force would tear these structures apart. One of those anchors is the supermassive black hole. This is the first image of Sagittarius A star, the gravitational core of our own Milky Way, which exerts a pull millions of times greater than the Sun. This model shows the galaxy's invisible skeleton, dark matter. It makes up most of a galaxy's mass, known only by its gravitational effects. Without this scaffolding, galaxies spin too fast. The stars would detach and fly apart into the void. The brilliant stars we can actually see are merely the outer skin of a galaxy. Its survival is dictated by these invisible mechanics. Spiral galaxies, like the Milky Way, are the universe's active factories. New stars are born inside these curved arms, fueled by massive gas clouds. Elliptical galaxies are the retirement homes of the cosmos. Shaped like stretched circles, they are filled with older stars and lack the gas needed to create new ones. Between these two are the disk-like lenticular galaxies and the tiny dwarf galaxies that often orbit larger giant structures as companions. These rules lead to stunning variations, creating structures that look like rings, or, in the case of the Sombrero Galaxy, a giant glowing hat. A galaxy's shape is a direct indicator of its cosmic age and its ongoing capacity to sustain new stellar life. Irregular galaxies have no clear shape. Their chaotic appearances are usually the scars of massive cosmic collisions and gravitational interactions. While these collisions look violent, individual stars almost never crash into each other. The empty space between them is simply too vast. Our own Milky Way is currently rushing toward its nearest major neighbor, the trillion-star Andromeda Galaxy. In 4 to 5 billion years, these two will merge. They will eventually settle into a single new giant galaxy. These mergers do not destroy the stars within them. Instead, the compression of gas triggers massive new star formation, making collisions the primary engine for galactic evolution. Individual galaxies are grouped into vast clusters and superclusters, which are separated from one another by massive, empty cosmic voids. Because light takes millions of years to cross these voids, we see distant galaxies exactly as they existed in the deep past. This delay allows us to study quasars, feeding black holes in the early universe that fired jets of energy so bright they outshine entire galaxies. Every galaxy we see contains billions of stars, and every one of those stars could host its own planetary system. The vacuum of space is a dense, living archive. When we observe these galaxies, we are witnessing the physical history of the